All right, so let's continue on with arthropods, which is our next phylum we'll talk about. We're going to talk about a little bit more detail. We'll actually move into some of the classes of arthropods. So again, we're in kingdom, we're in domain Eukarya, kingdom Animalia, phylum Arthropoda now. So the word itself, we've seen the root before. P-O-D, pod. What does it mean? It means having to do with feet. And arthro means jointed.
Tide pods. Hold on a second.
So jointed feet is what arthropod means. So what does that mean? What are the joints of your body? Your knees, elbows, your shoulder, your ankles. So joints are places where there's movement sort of allowed. And so arthropods have that name because their bodies are covered in a hard exoskeleton. And because they have a hard exoskeleton, they need these joints between the plates of their skeleton so movement is allowed. Like if you imagine, for example, a stormtrooper, you could think about a stormtrooper as having an exoskeleton, right? So it would not be very helpful if the stormtrooper had just an exoskeleton, this armor, in like tubes. 2 tubes for the legs, 2 tubes for the arms. Then you have to walk around like this. Your aim with your blaster would be even worse. So how are they able to?
They can't hit anything on
I know. How are they able to move then?
Don't.
They have joints in their armor. So there's a gap between a plate on the forearm and the upper arm where it allows for movement. And same thing at the knees. Think about a suit of armor. There are those gaps where there's plates that allow for movement to allow better mobility. Well, arthropods, these organisms that have this hard exoskeleton on the outside, they have those same features. So this ant here has a joint between these two plates, and here and here. So they have these joints between their plates of their exoskeleton allowing for movement. Arthropods are actually a really large group. Okay? About 75% of all animals are in this phylum. Okay? So it's a huge phylum. So there are several classes that are part of the arthropod phylum. We'll talk about that. This is one. Do you have any idea what this is?
Crab.
Do you know what would you call it? What like group is it in?
Crab.
I'm sure you've heard the word.
Shellfish. Crustacean.
Yes, these are crustaceans. Okay? The other classes, insects, arachnids, crustaceans, centipedes, and millipedes. I'll talk a little bit about each of them so you understand them. All of those things are arthropods. So there's a wide variety of types of organisms that you would find in the arthropod class. So centipedes, let's talk about their characteristics. The first one has 3 sections to its body. Its body is split into these 3 components. Has 6 legs, 2 antennae, and many of them have wings and fly. Which group is this? Yeah, that's insects, like this bee. So the insect group contains many things that you're familiar with, whether it's an ant, or a fly, or a bee, a wasp, a mosquito. These are all insects. Stink bug, ladybugs, beetles. All right, next group has only 2 body sections and has 8 legs. That's arachnids. Yeah, these include spiders and mites. So the next class has 10 legs, 2 pair of antennae. That's the crustacean. Lobsters, crabs, okay, they are part of this crayfish.
Oh, yeah.
And then we have our last two, which often people confuse. So one group has 2 legs on every body section. They're generally carnivores, they eat other insects and small little creatures. What group do you think that is? Yeah, centipede. And then the last has 4 legs per body section. Generally, it's an herbivore. Millipede. So they don't have 100 and 1,000 legs or 1,000,000 legs. That's, people sometimes say that. It's how many legs per body segment. So each segment of this centipede's body has 1 leg on each side, whereas the millipede has 2 legs on each side.
Wow.
So that's the difference. This is a giant millipede.
Hey.
All right. Now, many of these insects go through the process of metamorphosis. And metamorphosis is, there's a couple types. There's complete metamorphosis and incomplete metamorphosis. And some insects go through incomplete, some go through complete. So metamorphosis in general means an overall change in the body of an animal. And so some organisms have to periodically shed their exoskeleton. That's called molting. And many insects molt their exoskeleton. Why do they do this? It's actually, when an insect has molted its exoskeleton, it's actually a dangerous time for the insect because it doesn't have that hard shell around it, that protective coat of armor. After it molts, that's gone, and the insect's body is soft and it's vulnerable to predators during that time. So why would they do this? Sean?
Because like their exoskeleton has become too small for their body.
Yeah, the exoskeleton, once it is formed, doesn't grow. It's basically fixed in size. So for that insect to get larger, it has to shed this small exoskeleton, grow larger, and then form a new exoskeleton in the larger form. And every time it's going to grow significantly, it has to do that. So some organisms like the grasshopper and crickets, they go through this process. The stages are called the nymph stage, is the immature phase, which hatches out of the egg. And then there's sometimes several moltings until it reaches its adult size. And then in the adult size, it can reproduce. In our backyard, we used to have like one of those wooden swing sets, like made of cedar. And we would always find on that and on the fence in our backyard, these, my daughters were scared, these big, it looked like bugs that were like attached and not moving to our swing set every spring and summer. What they actually were just the exoskeletons. You ever seen these, like cicadas oftentimes? What happens is they find some sort of soft material that they can hold on to and grasp on, and then they molt out of their exoskeleton. You can usually see the split in the back. They come out in a soft form, fly away, but the remains of that exoskeleton still stay attached to that surface they were on. So that's what we were actually seeing, not real insects. It was just the exoskeleton. So this video is showing an example of a giant spider crab. This is a time lapse. A giant spider crab that is molting out of its exoskeleton. All right, the other type of metamorphosis is called complete metamorphosis. This is when the organism that is developing and metamorphizing goes through a change in which it almost looks like a completely different organism. And so the stages have different names. Typically, we call them the larva stage, the immature stage that hatches from the egg. Eventually it goes into the pupa stage, and from that emerges the adult phase. And so in organisms often that have this complete metamorphosis, the different phases sort of have different jobs. What's the job of the larva? To eat as much as possible, to gain energy, making it possible for it to go into the next stage. When it emerges in the adult stage, its main task is what?
Mate.
To mate, to reproduce, to lay eggs, okay, to have them fertilized, and then to produce young. Okay? So often we think of a butterfly as a classic example of complete metamorphosis. A caterpillar into a metamorphizing into a butterfly is complete metamorphosis. Another example, maggots
Ew.
go through complete metamorphosis to form flies.
Okay, this is really cool. One time I opened up this little fruit that I found outside, and it had a maggot in it. And I was on a school field trip. It was like last year or the year before.
Yeah,
It was like this.
often it's probably not a maggot, so that was probably the larva of some other insect. Like there are, have you ever seen, there are these galls that grow on sort of these weedy plants, called ragweed sometimes. It grows as a stem, has like yellowish flowers on it. And sometimes they have like this enlarged area on the stem that you can see. If you ever see one of those, if you cut it open, inside is a tiny little insect larva, okay, that lives in there and eventually emerges from there for reproduction. So that sometimes happens with lots of different types of insects. They're called sometimes grubs, if you've heard of grubs. Okay? Those are larval stage of various insects that are usually in the ground.
Sour cream and onion grasshoppers.
Find their shape.
Expanding, yeah, as it was drying.
All right, so let's talk a little bit more about insect anatomy. If we imagine a grasshopper. Grasshopper is sort of like a typical insect. They have sort of similar parts. We'll talk about the generalities of them. So, how many body sections did we say insects have? Three. Okay, they have names. So the front section is the easy one. What is it called? That's the head. And probably the end section is easy. The end.
The thorax?
No. Nope. The end is the abdomen.
The anthers.
And between them is,
The thorax.
yes. So you've learned this before?
The thorax.
Head, the thorax, and the abdomen are the three main body sections. The head is where you have most of the sense organs and the mouth attached. The thorax is where the legs and wings are attached. And then the abdomen is where the reproductive organs and some of the digestive organs are found. Insects have pretty good sense organs. They can smell and taste using the antennae. They have an eye. What's unique about most insect eyes? Yeah, they're called compound eyes. They're made of many lenses. Here you can see them. And so, we can't really say what an insect's vision looks like to them, but they can probably form many separate images that they somehow used to take in visual information. The head is where the mouth is as well. Insects have very specialized mouth parts. Some insects, prey on other insects. Others cut through leaves. Others have chewing mouth parts. So it sort of depends on what that insect is adapted to eating. The abdomen of the insect, if you were to look closely at each section, has these tiny little dots on them. They're holes. Do you know what they're used for? Ellie?
To like get out waste.
No, that comes out of the end opening. Edit? What? Yeah, those are these small openings that the grasshopper, the insect, uses for breathing. They're called spiracles. Insects don't breathe through their mouth. They breathe by taking air into these of small openings. They lead to a tube that leads to their internal organs, and that's how they obtain oxygen.
So they can eat and move at the same time?
Yep.
Wait, do they?
Meet the window.
Do they have to like use that part of their body to breathe in and out, or is it just like?
It just happens, yeah, air just goes in there. The end opening is called the ovipositor in the female insect. And the ovipositor is, so during mating, the male will deposit sperm into the ovipositor, and actually the female insect can sort of store it for a long period of time. And then the female insect can use that sperm to fertilize egg cells when necessary. So it's sort of a different way of reproduction than we're probably thinking. Most, or many insects, I shouldn't say most, have wings. They're attached to the thorax. And many insects actually have 2 pairs of wings, but sometimes the top pair is adapted to be a protective covering. For example, in what you might call a ladybug is a type of beetle. The red spotted part, those are actually wings, but they're not wings that are used for flying. When the ladybug flies away, those red protective wings flip up and allow the actual flight wings underneath to expand, and so it can fly away. Then when it lands, those flight wings sort of tuck in, and they're protected by that part of it.
Flight wings like stay out after they.
Yeah, sometimes they do. And then finally, 10 are the legs. They're also attached to the thorax. Like we said, insects have 6 legs. In some insects, they're adapted for different purposes. For example, in jumping insects, okay, like the grasshopper, they're larger hind legs and then smaller legs in front of those. Just sort of depends on how that insect evolved. So here we just see kind of a different, different view, but showing the same basic parts. There you see the different stages, the nymph stage versus the adult stage of our grasshopper.
It's on a window.
All right.
Oh
Now,
my god.
we're gonna
Ended here.
watch a couple of videos here about 2 types of invertebrates that are used in medical treatment. And have you ever heard of leeches being used in medicine? So you may think of that as something that happened in medieval times, right? That they would attach leeches to people, to take away, their ideas were that different humors in the body, different substances caused illness, and they would use leeches to try to remove them. But actually, leeches can be used today in medical treatments. They're used for some specific purposes, and so we'll learn about that. The other type of invertebrate that's also used in medical treatment that you may not be familiar with are fly larvae, which we would call maggots. So maggots are actually used as a medical treatment in certain conditions. Now, where would you typically find the maggots?
I found like a lot of
Garbage can?
Yeah.
Why are they in the garbage can? They're eating, what do maggots eat? Rotting flesh. You might see them if you were to walk by in the road, walk by a roadkill that was on the side of the road. If you look at it, most times you're trying to just keep going past quickly, but you might see maggots crawling all over it. That's because they consume the dead, decaying flesh of that roadkill. They do not consume healthy flesh. They don't eat healthy tissue. So can you imagine what they might be used for in medicine?
Oh, like getting rid of like old skin.
Yeah, you're on the right track. Some people have wounds that do not heal, that for various reasons are not getting better, and that that wound, as it decays, sort of gets bigger and bigger. And some people that have like a severe foot wound that's not healing may have to have their foot amputated to stop the infection from spreading throughout their body. So what sometimes doctors will do is pack some newly hatched maggots into the wound and seal it up.
Seal it up?
Those maggots will consume what? The dead tissue, the bacteria, the infected tissue. They will not consume any of the healthy tissue. Because in these situations, usually, traditionally, what the doctor would do would surgically remove the decaying diseased tissue. But they have to, take away a large part around the wound as well. And so if they have to continually do that because of recurrent infections, the surgeon ends up removing more and more of the person's tissue. These maggots only consume the decaying and diseased tissue. They can actually encourage the healing process and allow these wounds to heal much better than a surgeon would be able to do by doing actual surgery. So we're going to watch the video about showing. It does show, so I know some of you are a little squeamish, it does show some open wounds that people have. It does show the maggots in the wound, and it talks about how this actually works.
That I found somewhere.